Hello everybody. Today we will start our lesson perpendicular and angle bisector. What is the meaning of perpendicular? If I draw a line segment like this and draw a line, this line makes angle 90 with this line, so it's called the perpendicular. If I have midpoint here like x, here A and B, then if x is a midpoint, then it's called the perpendicular bisector. Let us move to the perpendicular bisector theorem. If BM straight line is perpendicular to AB line segment, here BM is perpendicular to AB, and the MA equals MB, then BA, length of BA, if I join between B and A like this, must be equal length of BB. Let us read the theorem. If a point is on the perpendicular bisector of a segment, this point P is on the perpendicular bisector of a segment. We said before perpendicular bisector, it means it makes angle 90, and this point M is a midpoint. Then it is equidistant from the end points of the segment. What is the meaning of equidistant, and what is the equidistant point? P is equidistant from the end points of the segment. It means length of PA is equal P length of PP. That is the meaning of equidistant. It means equal distance. So if I have PM is perpendicular to AB and MA is equal to MP, then PA is equal PP. Let us move to the converse of the perpendicular bisector. Converse, it means if I have PA is equal PP, length of PA is equal length of PP, and I draw a line like this passing through this point P, then this line must be a perpendicular bisector. We know that PAP, triangle PAP, is an isosceles triangle. So if I draw the line passing through this point P, this line becomes a perpendicular bisector. It means the measure of this angle 90, and length of this side, I consider it M, PM is equal to MA. Here I have angle bisector theorem. What is the meaning of angle bisector? Angle bisector, we said before I go to the theorem, if I have angle like this and I draw line, this line bisects this angle. It means the measure of this angle must be equal measure of this angle. That is the meaning of angle bisector. What about the angle bisector theorem? If a point is on bisector of an angle, then the point is equidistant from the sides of the angle. Here I have QS bisects the angle PQR. QS bisects the angle PQR. It means the measure of angle PQS is equal to measure of angle SQR. And I have a point lies on this bisector. This point is called S. This point is equidistant from the sides of the angle. It means length of SP is equal length of SR if SP perpendicular to this side and if SR perpendicular to this side. Okay, so I have a point lies on this bisector and SP perpendicular, SR perpendicular. It means so I have length of SP is equal length of SR. Also, I have the converse of the angle bisector theorem. The converse, it means if I have point in the interior of an angle of the equidistant, I have point like S. This point is equidistant from the sides of the angle. It means SP is perpendicular. SP is equal SR, and also SP is perpendicular to SR. If I find that, then the line which is drawn passing through S is bisector for this angle. If I draw a line like QS, then this line is bisector for this angle. Let us see some exercise to solve about this. Here is figure at the right for this exercise from 6 to 8. What is the relation between MA, MPs, and JK? MP and JK. What is your opinion? MP, we find that MP is perpendicular and B is the midpoint. So MP is perpendicular to JK. That's the relation between MP and JK. What is the value of X? We said before, if I have perpendicular bisector like this, and we have M point M lies on this perpendicular bisector, it means it is equidistant from endpoints of line segment. What is the meaning of equidistant? It means length of MG must be equal length of MK. So to find the value of X, I can make like this. 9x minus 18 is equal 3x. It's easy to solve this equation because it is a non-variable x. Yes, we combine like terms. I can move 3x here to the other side. It will be 9x minus 3x. And I move the negative 18 here, like this. It will be positive. And I move 3x here, becomes negative. So 9x minus 3x equals 18. It means 9x minus 3x is equal 6x. 6x equals 18. So to find the value of x, dividing both sides by 6, it will be 3. Now I found the value of x. Here I found the relation. Next step or next question, I wanted to find length of Jm. Jm. I know that the value of x is equal to 3. And I have here Jm is equal 9x minus 18. So by substitution for x, means I can remove x and I put 3 instead of x. It will be 9 multiplied 3 minus 18. So equals 9. Also I can make substitution here. 3 by 3 directly equals 9 because I know that mj is equal to mk. Yes, now I know that if I have perpendicular bisector like this, so the point which lies on this perpendicular bisector is equidistant from ends of a line segment. It means mj is equal to mk. Let us see another exercise. Use the figure at the right for this exercise from 12 to 15. Here I have figure like this. According to the diagram, how far L from HK, that's the first question, and from HF. I wanted to know how far is L here is L, from HK, where is HK? HK here. Far, it means the perpendicular distance between L and HK. Yes, 27, right. And also, from HF, I have these two sides are equal. LK is equal to this side. Right? It means it's equal to 27 also. So, here the far is L from HK is 27, and from HF also is 27. Exercise number 13. How is HL is related to the angle KHF? I wanted to know the relation between HL and angle KHF. We found that L is equidistant from HF and HK. So HL must be bisect this angle. Then HL is bisector for this angle. HL bisects angle KHF, and the L is equidistant from HF and HK. Question number 14. Find the value of y. Y, here I have measure of this angle 4y plus 18, and the measure of this angle 6y, and we said before that HL is a bisector. It means the measure of this angle is equal to measure of this angle. So I can write like this. 4y plus 18 is equal to 6y, or 6y is equal to 4y plus 18. So I can solve for y. I move 4y here, it will be negative. It will be 6y minus 4y equals 18. 6y minus 4y, it will be 2y. It will be 2y. 2y is equal to 18. By dividing both sides by 2, so y is equal 18 divided by 2, it will be 9. Now, I solve this question. Find the measure of angle KHL and FHL. We know that if I find the measure of angle KHL, so directly equals the measure of angle FHL. It means here I know that measure of angle KHL is equal to 6y. So I make multiplication. I remove y and I put 9 instead of y. It will be 54. It will be 54. Then we'll go to another exercise here. Exercise number 16. Find the x, jk, and jm. I wanted to find the x, jk, length of jk, length of jm. Here I have measure of angle KLJ is equal measure of angle MLJ. It means LJ is a bisector. And here I find that JK is perpendicular and JM also is perpendicular. So J is equidistant from LK and LM. It means this side is equal to this side. So I can write like this. 2x minus 7 is equal x plus 5. If I move x to the other side and the negative 7 to the other side, it will be 2x minus x equals 7 plus 5. I can solve this equation. It will be x is equal to 12. Now I find the value of x. So, value of x, I need to find jk. To find length of jk, so I make substitution here. I can remove x and I put 12 because I have jk is equal x plus 5. It means 12 plus 5 is equal 17. Also, length of jm directly is equal 17 because I know that jk is equal to jm. I don't need to make substitution here because already I know the length of jk. So I move to another exercise number 17. Here I wanted to find the value of y, st, and tu. To find the value of y, if I look at this figure, I find that measure of this angle is equal measure of this angle. You put the same signs here. And TS is perpendicular to SV. It means the measure of this angle 90, and here also 90. So VT is a bisector for this angle, and TU perpendicular to VU, and TS perpendicular to SV. It means TU is equidistant. T is equidistant from UV and SV. It means the length of TU must be equal length of ST. So I can write like this. 5y is equal to 3y plus 6. Now I move 3y here, it will be negative. So 5y minus 3y is equal 6. 5y minus 3y, it means 2y. 2y equals 6. To find y, dividing both sides by 2, it will be 3. So the value of y is equal to 3. I want to find the value, the length of ST, which equal 5y. So I take 3 and I put it here instead of y. It will be 5 multiplied 3. It will be ST is equal 5 multiplied 3. It will be 15. And also TU is equal 15 because they are equal. Let us move to another exercise. Here, use the figure at the right for exercise from 18 to 22 to find the value of x. That's exercise number 18. If I look at this figure, I find a lot of things. Here, WY is perpendicular to TZ, means the measure of this angle 90. And the y is the midpoint of TZ. It means YZ is equal to ty, and here wy is considered as a perpendicular bisector. It means that w is equidistant from z and t. It means the length of wz is equal to length of wt. So to find the value of x, I can make 3x minus 5 is equal to x like this. 3x minus 5 is equal to x. I can solve this equation like previous. I move 2x to the other side, it will be 3x minus 2x equals 5. 3x minus 2x, it will be x. So x is equal to 5. I wanted to find length of tw. We know that tw is equal to x. tw equals to x, so I have x is equal to 5. Then 2 multiply 5, it will be 10. So I find length of tw. Length of wz, it is the same because they are equal. I can write directly is equal to 10. If you want to verify your answer, if you make substitution here by using x equals 5, it will be 10 also. So I found length of wz. What is the kind of triangle TWZ? TWZ. The kind of this triangle is an isosceles triangle because I have length of this side is equal to length of this side. So this triangle is an isosceles because WZ is equal to WT. The last one, if R is on the perpendicular bisector, let us clear this, and R is on perpendicular bisector TZ. Perpendicular bisector of TZ. Where is the perpendicular bisector? Yes, WY is called the perpendicular bisector. If I put point here, this point is called R. This point is called R. Then R is a space from T and Z. R is a space from T and Z. Yes, right, equidistant. I can write equidistant. Or RT is equal to RZ. Let us treat like this. RZ and RT. Then if R here on WT is a perpendicular bisector, it means RT is equal to RZ, or I can say that R is equidistant from T and Z. Thank you for watching. Meet you in the second session. Goodbye.